All right, now we're going to be looking at different types of graphs, drawing and recognizing graph types. Okay, different types of graph that you need to know. Number one, the simplest of graphs. Things like y equals 3. Y equals 3. What would that look like? Well, if y is equal to 3, the value of y is constant. The only place where y is always equal to 3 is along here. So I'll draw the graphs in green, the axis in blue. If this value here is 3, then this is y equals 3. Okay. Let's do the second one. What happens if it was something like x equals minus 2? Okay, I'll draw some axes. Should really label these y, x. If x is minus 2, then x is always minus 2. So here's where x is minus 2. So we're talking about a line that is vertical. Oh, I said I'll do that in green, so let's do that. X equals minus 2. You can notice anywhere I put my cursor along that green line, the value of x is minus 2. So that's why it's x equals minus 2. Okay, they're the really simple ones. Let's do the next most simple, probably. The good old y equals mx plus c. So here we're talking about straight lines. Remember that m is the gradient. And c, this value here, is the y-intercept. Okay, so this would be my c here. And my gradient, remember, is rise over run. So remember, we might need to remember that. Gradient is rise over run. Remember that positive gradients are going up bottom left to top right. Now, I always remember that if you put your right hand up in the air, I am absolutely useless at drawing, but let's say we've got some chap here sitting in class and they put their hand up in the air. I know the answer to this. They're putting their hand up like that. They're really positive that they know the answer. And so the angle that it's making is top right, bottom left. If somebody grabs hold of their arm and twists it round here, ow, that hurts. That's really negative. So here we've got a positive gradient over here. Oh, excuse me. Positive gradient. This is negative over there. Somebody's bending their head, bending their right arm. Maybe I should draw that separate diagram here. They basically, this chap is sitting here and they've got their right arm and they're bending it round like this. Ow. Negative. This is a negative gradient. That's how I remember it anyway. So they might look like something like that, or maybe something like this. So this has got a negative gradient. This would be y. An example of that might be y equals minus x minus 4. An example like this might be something like y equals positive x plus 4. Okay, so the value here, c, would be 4 in this case because the y-intercept is 4. Here this would be minus 4 in this case. So the straight line graphs, they look like that. Now you might get ones that are rearranged a little bit. So 3.1, you might get ones that look like ax plus by equals c, because we could rearrange that. If we subtract ax from both sides, we'll get by equals minus ax plus c, and if we divide both sides by b, we get y equals minus a over b x plus c over b. This is in the form y equals mx plus c. M is this gradient, so the rise is A and the run is B, and it's going in a negative direction, and the y-intercept is C over B. But they're still, as long as they can be rearranged into y equals mx plus c form, they're still straight lines. Okay, so that's horizontal lines, vertical straight lines, other types of straight lines that aren't vertical and horizontal. They're actually called oblique lines, but anyway. Other types of things we might need to know are quadratics. Y equals ax squared plus bx plus c. Now we need to remember that they might look U-shaped or they might look N-shaped. Okay, now what depicts whether they're U-shaped or N-shaped? Well, it's this value of A. This is called the coefficient of x squared. In other words, how many x squareds we have. If the coefficient of x squared is positive, in other words, greater than naught, then we have a U-shaped. Positive, okay, A is positive, and positive is happy, so it's a U-shaped. Here, A is less than naught. A is negative, and if you're negative, you're sad, and you've got an N-shaped mouth there. Next type of graph that you need to know the look of are cubics. Now they look something like y equals ax cubed plus bx squared plus cx plus d. And you simply need to remember that they either look like this, or they might look something, I'll draw on the same graph in a different color. They may look something like this. They might dip back below again and go back up. They're basically looking like they've got sort of two loops like that. Let's draw a y on our x-axis again. Or they might look something like this. They might start up there and go up there and back again. That's not a particularly good one. Yeah, something like that perhaps. Okay, these are cubics. That's what they look like. The simplest cubic of all might look something like this. Okay, so they're essentially got this sort of double loop in them. Now, if A is negative, okay, then what we've got there, if x is negative, so in other words, let's choose a value of x over here, right? A negative cubed is negative. So if A is negative, we're multiplying a negative with a negative, which is a positive. Okay, so if A is positive or negative, we'll depict the shape of whether it goes bottom left to top right or top left to bottom right. Okay. Other ones that we might look at are, we might look at exponential curves. So exponential curves are ones that grow really fast when, for example, like this, you can see that as x is not changing a great deal, 1, 2, 3, the values of y are changing quite rapidly. When x is 4, it's really starting, the distance between here and here, starting to grow a lot. These are called exponential curves, and they look like something like y equals 2 to the x, or y equals 5 to the x, or something like that. And the reason why they're called exponential curves is because the power, another name for power, is called the exponent. So if you've got an unknown letter on x, if you like, in the power, then it's called an exponential graph. You might see some, this is exponential growth, by the way. If you've got exponential decay, then you might start off large and it basically decays down to something really, really small. So this one is exponential decay. And those things look like y equals 0.2 to the x and things like that. So in other words, if this value here is bigger than 1, we get exponential growth. If this value here is less than 1, we get exponential decay.